There we go.
Yep.
Okay, so we're looking at 16, 17. Obviously, you're basing your workings on demand and supply. Okay, you've got PDPS, and they're asking you for consumer surplus. Okay, so how do you do consumer surplus when you have a function like that?
So yeah, that's obviously not a linear line. It's not non-linear. So you have to use the derivative.
No, not the derivative. You have to use that equation for surplus.
Yes, I've got it here on my notes. Let me just check here. Um, I thought I had it. Oh yeah, yes. Um, yeah, so non-linear. Um, it is elasticity of demand, or no?
No, no, no. That's something different. This is consumer surplus when it's non-linear.
Oh yeah, consume. Yeah, sorry. Yeah, yeah. I'm not sure what the formula was.
Okay, it's the integration one, hey?
Yes, yeah.
Okay, where you have the demand function, and then you're going to subtract the P and the Q. Remember that?
Yeah, yes.
Okay, so how do you do integration when you have something like this? So you're basically integrating naught to Q. Obviously, Q you need to solve for. Okay, P is 10. How do I get Q?
So you're going to substitute it probably with 10.
Yeah, substitute in, right? Okay, so
Yep.
P, this is QD. So QD would be um, Q, quantity, and then obviously substituting in the P of 10. So this P is going to be 10. All right, can you solve for Q? Do you know how to do that?
Um, yeah, you see, that's where I wasn't sure. I saw in the workings you used logs, natural log.
No, no, no logs. No logs for this
Okay.
one.
Oh, you're just going to apply both sides by q plus 3.
Yes, yeah, you're going to take this to
Yep.
that side. So if you take the
Yes.
denominator to the left, it becomes multiply.
Yep.
Okay, happy with that?
Okay. Yep.
Okay, and then what do you do? You've got
Okay, so
to
then you
work
have to
out
use
the
that formula that.
integration. Yes, you've got to use the formula,
Yep.
right? So Q is 1,
Yep.
and then you're looking at integration for this thing. So
Yes.
40
Yep.
Q plus 3. Okay, so how are we going to integrate this? We need those rules. So if you go to the textbook or if you go to your study guide, let's see here. Okay, so derivative to function. Here I have qd plus 3. So if I've got qd plus 3, that says I've got a denominator with qd. So then I have to use, let's see which one. I can use the 1 over x to the ln x if I'm going from derivative to function. So the
On which page are
textbook,
you looking now?
I'm just referring to the textbook. The textbook gives you a function and
Okay.
then a derivative. So the rule is when you have ln x, the derivative would be 1 over x. So obviously if I'm doing integration, I'm
Oh,
going that
yes, yeah.
way.
Oh, okay. Okay.
Okay, because remember integration is the opposite of
Yes,
differentiation.
of the yeah differentiation.
Okay, so derivatives, function to derivative, integration, derivative back to function basically.
Okay.
Does that make sense?
Yes.
Okay, so then when looking at the substitution that's working, let's see what I did here. I've got the workings open. Let me bring it across, and then you can see what we did here. This was 16, yeah. Okay, so yeah, same formula. There's the formula. And then there's the solve for Q. Okay, so what we're looking at here is the integration. So when I'm integrating 40 over QD plus 3, okay, here I used U equals Q plus 3, all right, and then I had du over dq. So the derivative of this would have been 1, okay, and then you're looking for the integration of 40 over u, okay, so the answer there would be 40 ln u, right, and obviously ln u, the u would be q plus 3, right, so that's what we got there at the end.
Okay.
Oh, okay, I see here I used 10 instead of 1. That might have been a mistake when we did this. I put a P here instead of a Q. Let's check that formula. Okay, yeah, that's a mistake there. The equation here is from 0 to Q. Do you see that?
Yeah.
Okay, so I do need to correct that actually. This needs to change. Okay, obviously it will be 0 to 1. Let me just see if I can, what can I do here to write here? I think this will work. Yeah, okay, so that needs to go out. Okay, so it's going to be 0 to 1. Let's check the substitution. Did we have that here? I had 0 to 1. Yeah, this I need to fix. Okay, so when you're looking at that, so you've got 40 ln q plus 3. Okay, 40 ln q plus 3. So it's basically... Okay, and then obviously from 0 to 1. Alright, so then if I'm looking at 0 to 1, I'm going to have to substitute that in. Okay, so your consumer surplus would be 40 ln. Okay, so it'll be 1 plus 3. 1 plus 3 is 4. So this should be a 4, not a 13. Okay, and then we've got 40 ln 3. That's correct. Okay, so obviously it's just the 1, not a 10. Okay, and then you've got P times Q. P times Q is 10 times 1, so that's fine. Alright, so we just need to fix the first bit. Okay, so the first bit, 40 ln 4 is how much? 40 times bracket ln bracket 4. Close bracket, answer. Okay, 55.45. So this figure needs to change. 55.45177. Okay, and then let's update the answer. Maybe we'll get an option that's there. I think last time we went with none above. Let's see what we get now. I get 1.5. Yes, there we go. Okay.
Okay.
All right, yeah, you do get the right answer. So let me correct this. Where's my answer for this? There, option 5. Okay, that I need to correct. Okay, so when we did this the first time, obviously here, there's an error here. Okay, so when I did the integration, the definite integral, I used 0 to 10. Okay, I think I might have just put a 0 incorrectly, or maybe I used the P incorrectly, but yeah, it's 0 to Q. Q was 1, P was 10. Okay, so that's obviously an error. So if I correct it, that's the correct working, that's the correct calculation, and then the right answer is 1.5. So 1.5 is option 2 actually.
Okay.
Okay, so question 16, 1.5 is correct. All right, yeah, that's good. It's good we're going through these again. I'm spotting, well, one correction there. in terms of the working. All right, great. What was the next one?
17.
Okay, 17 as well. Okay, producer surplus. So producer surplus, what do you have here? Is that linear,
Okay.
non-linear?
That's non-linear.
Non-linear, yeah. Q squared, hey?
Yep.
Okay, so producer surplus, you're going to need that formula. There's the formula. Producer surplus, revenue at market price, times the acceptable revenue at the lower price, and then they give you the P0, Q0, okay, minus the area under the supply curve. So, supply, PS equals 3 plus Q squared S. Do you see that?
Yep.
Okay, so obviously it's going to be PQ minus the integration of that thing. Okay, so how do you integrate that? Well, this would be this would be 3Q, and then this will be add 2, hey? So 2 plus 1 is 3. So Q3 over 3. And then from, it should be 0 to Q again. So you'd have to substitute Q in. Okay, so let's look at it there. There's the PS equals that. Substituting the P. Okay, the P here was what? 19. Okay, so to work out the Q, if I plug in 19, 19 equals 3 plus Q squared. Okay, obviously I'm going to subtract, so I'll have 16. Let me show an extra line here. I'll have 16 equals Q squared. Okay, then obviously Q can be plus minus 4. Okay, but you can't have negative quantity, so Q must be 4.
Oh.
Right, so now you've got Q4 and P19. Okay, so producer surplus, area under the supply function, okay, over 0 to Q. Okay, so where's my supply function? There's my supply function. All right, so there's my integration. Okay, so I integrated 3 plus Q squared, Q3 over 3 plus 3Q, same as what we had there. Okay, obviously 0 to 4. Why 0 to 4? Because it's 0 to Q. And Q is obviously 4. Does that make sense?
Yep.
Okay, and then once we've got that, then you've got to plug in the 4 and the 0. Okay, so I put in the 4 here, and I'll put in the 0 there. All right, so 4 to the power 3 over 3 plus 3 to the 3 times 4. Okay, working that out on the calculator gave me, I think it was 33,3. And then minus obviously 0 here. Do you see that?
Yep.
Okay, and then going back to the formula said P0Q0. Okay, so what is P0? It was 19. So 19 times 4 is what? Let's work it out. 19 times 4 is 76. And then you're subtracting, okay, the area under the supply function, which is what we calculated there, the 33,3. Does that make sense?
Yep.
Are you sure?
No, I think I just need to practice these integrals.
Oh, okay. These, so
Yeah.
this step, eh?
Yeah.
The definite integral. Okay, so how do you get a definite integral? So maybe just to recap that, when you're looking at a definite integral, so this is the theory. Okay, this is a function, and then you get a derivative. So when I'm looking at x squared, okay, how do I get the derivative? 2x. Do you agree?
Yep. Yep.
Okay, so the formula, the general equation is given in the textbook. Basically, you're subtracting 1 from the exponent and you're multiplying that in. So I think they give the notation like this. Something like that.
In minus 1. Yeah.
Yeah, in the textbook. Okay, that's to get a derivative. Do you agree?
Yeah.
Okay, so if you're
Yes.
going from here to there, That's integration. Okay, so what would that look like? Well, let me just show it to you. I just want to get this so I can change the color. Okay. Alright, so if I'm going from integration, well, derivative to function, I need to use integration. Okay, so that's what you'll have. And then the rule to do this would be, I think the rule says, let me just think about it now, n plus 1 over n plus 1. Something like that. That's also in the textbook. Are you following?
Yes, yeah.
Okay, so when you're looking at the integral, to get from derivative to function, okay, I'm going to write down 2x. Then what am I going to do? Add 1. Then
Yes.
what am I going to do? Divide by 1 plus 1.
By.
Okay, so what is 2 over 2? 1. X to the 2, there's it. Okay, and obviously plus c.
And then another thing I'm struggling with is obviously the notation of the that you're doing an integral and the 0 that you usually put at the bottom at the 1 at the top.
Oh, okay, yeah, that's a definite integral. Okay, so when you have a 0 and a 1, what does that mean?
Yes.
That means you're going to substitute in 1 into this. So it'll be x squared plus c. Okay, this would equal, well, let me do it this way. This would equal 1 squared plus c, okay, minus 0 squared plus c. Okay, so obviously 1 squared is 1, so 1 plus c, okay, minus 0 plus c. Okay, obviously a plus c and a minus c gives you a 0, so you're left with 1. Does that make sense?
Okay, yeah.
Yeah, so
you always take the top part first and then subtract the bottom part.
Correct. So whatever this is, you're going to plug that into this function, and then you're going to do this for the other thing as well. Plug in the 0 for the function, yes. Okay, and the notation can be like this, or the notation can be like this.
Okay. And what you put at the top all depends on the formula, whether you're doing consumer or producer surplus.
Yeah, it'll be that formula. So where's that equation?
Yeah. Okay.
Equations.
I think in the workings.
Yeah, the equation looks like that. Okay, area under the graph. So it should look like this. There's it. Okay, that's how you write it.
Okay.
Okay.
Okay, but this one states it clearly. 0 to QA. If you go back to 17.
Yeah, this is area under the supply function over 0 to Q. So it's just written in a different notation. It's written in Word instead of mathematics.
Yes, okay.
Okay, so they're just telling you, so if I had to write this in maths, I would write this. 0 to Q for the supply.
Okay.
Does that make sense?
Yes.
Okay, you sure?
Yeah.
Okay.
Yes.
All right. What are the questions? Do you want to go through? So 17 was, I think it was 4, if I remember correctly. Yeah, 17 was 4.
Yes. Okay, next one I think was 22.
Okay. All right, yeah. Find the derivative of the function. Okay, so when you have lots of terms, you have to make this all in this notation. Okay. All right, so how do I get this into that notation? X is a half. Okay, when you have a square root, it means the power half. Okay, and then you just apply your derivatives. Did they want the derivative? Yeah, they did. Okay, so 6 times 3 is 18.
Yep.
6 minus 1 is 5. Okay, when you have this as a minus a half, you would write it as this. Okay, the minus a half means it's in the denominator. And because it's a half, it's obviously a square root.
Now that's the part that that I was struggling with. Obviously, the inverting.
Yes.
Another question I had now was I was looking also at the one example. I can't remember the question, but it was also with a fraction where you had to invert it to make it positive. But I think it was something like 4 over x squared, I think.
Okay, if you've got that, okay, this could be written like this.
Yeah, 4x minus 2. So I don't understand, why do you make it 4x? Do you multiply the 4 with the x? I can
No,
understand
you're just
inverting
writing
the x.
this in the numerator. Because remember, when you have, so x, okay, x to the 0 is what?
It's 1.
Correct. So if you had to write this down, you could write it like this: 4x to the 0 over x to the 2. Okay, when you have this and that, what do? You subtract because you have division. So you could have
Yes?
4x to the 0 minus 2. That's another way of looking at it. So basically, if you have anything in the denominator, okay, how would you write that without the
So
fraction?
that x to the power minus 3.
Yes. Okay, so when you have a negative 3, it just talks about if it's in the numerator or the denominator. If you had something like this, okay, then that would be the same as x to the 1. Okay, because this just means move it to that side.
Okay.
Okay, or if you had to rewrite this, you could say 1 over x. That would be 1 divided by 1 over x, which is the same as
And then you
1
spot them
times x over 1,
times
which is
x. Yeah.
x.
Okay.
Okay, is that right?
Yes.
Yeah, so these are just a few basics in terms of your exponent rules. Let me just check and see if I can maybe show you in your study guide. Let's go to the study guide and see if there's a page that you can maybe use as a reference. They should give you the rules. Okay, why do I have two open here? Oh, this was 2018. Close that. Okay, so let's see. Do they give you a list of rules here for exponents? They should. Probably in the basics, I guess.
So I did basically, I'm working off. Can I enter anything in the chat over here? I
Sorry,
don't
what's
think.
that?
Yeah, no, I did get something on the internet on Google where what I'm basically using for the rules, exponent
Okay.
rules.
Yeah, normally good textbooks like you could probably if you have old textbooks maybe from like high school or something like that, you will probably find those rules there. So these are obviously fractions. Okay, laws of operation. That's BODMAS. Fractions.
Yeah.
We're looking at exponents. Okay, see, I don't see exponents here. I see it here, nonlinear. There, working with exponentials. It's probably there, 179. Okay, no, not quite. These are still graphs. Okay, yeah, there we go. Here, there's it. Okay, when you have exponents being multiplied, you add. Do you see that?
Yes. Yeah.
Okay, here when you have divide, you minus. Do you see that?
Yes.
Okay, so there's some basic examples. Okay, when you have an exponent being raised by an exponent, then you have that multiplication. All right, so they actually do give it to you. There are the rules there. So this is the
Okay.
rule that I'm using, basically. Okay, so for example, if I had x to the 1 over x to the 4, that would be what? X to the 1 minus 4, which is x to the minus 3. Or you can just say, cancel, 1 over x to the 3. So 1 over x to the 3 is the same as that. Does that make sense?
Yes.
Yeah, so these are just some basics. Looking at exponent rules, yeah. This page I would probably keep somewhere. Page 179. Just those
Okay.
rules, that's all. Okay, have a look at this there. Here, Eunice is giving you some practice examples. Right, 2 to the 5 over 2 to the 3 and 2 to the minus 4. Okay, so that's how they've done it. You could have done it this way. Okay, what could you do? You could write this down as 2 to the 5 times 2 to the 4 over 2 to the 3. And then cancel 1, 2 to the 6.
Okay.
Okay, so you can just move it left and right, not left and right, up and down. Okay, because it's a minus 4, you can bring it to the top.
Okay.
Okay. All right, are you okay with this one, hey? Which one is it? This one.
Yeah. Yes.
Okay, so the answer was 4. Okay. Which other ones?
Yeah. So I basically just asked. I just wanted to make sure that I understand it correctly.
Okay, yes.
Next one, I think 24.
24. Okay, so this one.
Yes.
Okay, when you
Yeah.
read this
Marginal
question, what are you
cost.
thinking about?
That's so. Yeah. Obviously, marginal cost. So you have to go backwards. You have to integrate again to get.
Yes, so marginal cost is the derivative. Do you agree?
Yes.
So if I integrate marginal cost, I'm going to get what? Total cost. Does that make sense?
Yes.
What did the question ask for?
For profit.
How do you work out profits?
So yeah, obviously profit is total revenue minus total cost.
Correct. Okay, so you need this, and revenue also need. How do you get revenue?
Revenue is price times quantity.
Yes. Okay, so if the product is sold for 20 and the quantity is Q, there's your revenue function. Do you see that?
Yes.
Okay, then your total cost function is going to be the integration of Q squared minus 442Q plus 200. Okay, so to integrate this, I'll have Q to the 3 over 3 minus 42 to the Q squared over 2 plus 200Q. Does that make sense?
Yes.
Okay, and then obviously divide here, so 21. All right, so that gives me the total cost function. So total revenue minus total cost. Okay, so 20 times Q is 20Q. Do you agree?
Yes.
Okay, so 20Q, and then obviously I've got a minus here. So a minus and a minus is a plus.
Plus.
Is that right? No, this is a minus and a plus is a Minus. Does that make sense?
The minus, yes.
Yeah, so it's
Yeah.
minus 200 plus 20. Do you agree?
Yes.
Okay, so minus 200 plus 20 is minus 180. Okay, and obviously negative times that. Negative times a negative is a positive. And there's your profit function. Profit, they just use that as notation. Okay, so which option? Minus 1 over x to the 3 plus 21q squared minus 180q. So it looks like 3. What number is this? 24. Oh. Almost forgot. The plus 900 is the fixed costs. Okay, so remember when you have integration, okay, when you work out this integration, there's always plus c here. Okay, I forgot to add the plus c. Alright, the plus c here is 900 because that's the fixed costs. Okay, so you got a plus c here. So a minus times a plus is a minus, so you've got minus 900. Okay, can't forget about that.
Okay.
Okay, yeah. So the answer that I had got previously was 1. Option 1 is correct. Okay, it's the same as 3 except it's got the fixed costs as well. Okay, there's the integration. See it? Okay, TC is
Yes.
the integral of marginal cost. That's what I've written there. Okay, so the total cost is the function there. Okay, and then obviously this is going to be plus c. Just to show that. Okay, the right answer is there. Okay, I think maybe these are the ones that I had done after you left because you had to pick up your daughter. Maybe that's why
Yes.
I didn't go through these with you.
Yeah.
Some of them I know I did, and then I sent you the answers because we ran out of time.
Okay.
Okay. All right. So does that make sense now? Are you okay with that?
Yeah.
Okay. All right. More? Which ones?
Okay, so then moving over to the next exam, the June 2019.
Oh, okay. New exam. Okay, let's close this. Okay, May, June 2019.
Okay, so the first one is question 10. Oh, sorry, I mean question 9. Question 9.
Okay. All right, here's it. Let me just close this file. Let me just save this, and I'll just close this. And then let's open up the May, June one. So then we have it. Okay. All right, so... Oh, here we go. Here's an exponent one. Don't you want to try this one?
Okay, yeah, we can.
Okay, so if you had to work this one out, if this was in the past paper tomorrow, if this is in the exam, let's assume this is an exam question. It might not look the same. It might look similar. If it looks like this, what would your approach be?
Okay, so first of all, I'll basically simplify by the bottom. You can probably multiply that with itself, obviously, to remove the
Rainer,
exponent.
I think let me do this. Where's the Zoom thing? I want to give you here. Let me more. You can write on the screen. Let me just see, how do I do this again? Here. Oh, I think you can actually write on the screen. I don't have to give you that option. I think you can do it already. If you go to your options here on Zoom, you should have an annotate button here.
Annotate, yes.
Okay, then you can write on the screen. So show me your answer. There we go.
That's
brilliant.
Working. Okay. Okay, so where eraser.
It's working. Awesome. Nice. Okay, so Reno, you do your workings on screen. So actually write your answer here, and let's see what it looks like, and I'll correct it if it's wrong. Okay, let's see how good you are with your exponents. Okay, let's try that. I'm obviously going to erase this, but yeah, go for it. Write down your answer. What would you have if you had to do
Yes, so
this?
let's see here. Okay, so when you basically multiply, that means you can add them. Okay, but they have to be the same.
Okay, let's go
They're
back to this.
already.
Let me show you these rules again. Okay, so when you have an exponent being multiplied by an exponent, so for example, 2 to the 3 times 2 to the 5, I'm going to add the exponents, 2 to the 8. Does that make sense?
Yes.
Okay, when you have division, all right, so for example, 8 to the 6 divided by 8 to the 3, okay, then I'm going to subtract. I can cancel like that, or I can say 6 minus 3 is a3. Does that make sense?
Yes.
Okay, when you have a scenario like this, y to the 2, open brackets, to the power 4, then I'll have y to the 8. I multiply those exponents when it's raised by a bracket. Do you see that?
Okay, yes.
Okay, so those are the rules that you need in order to complete this equation. Okay, so I'm going to shrink it a little bit just so we can see, just so we have more space. Okay, so there's it. Okay, you've got lots of space. You can use all of the space here. You can write wherever you want to, but I want to know, okay, what is this going to look like step by step? So go through it each step. So show me the workings. Do step number 1, do step number 2. Actually write it down.
Okay. So that probably means I can multiply these all with -2.
Well, yeah, you need to get rid
With
of the
that,
bracket. That's the first step. Get rid of the
yeah.
brackets.
So
Okay, so show me your step to get rid of the brackets.
one here. Draw with format line. Sorry, I selected the draw tool now. I don't know.
Okay, yeah, don't worry, that's fine. There should be one that has a
making
writing
an arrow.
tool. There should be a pen
writing.
or something. Annotate.
Okay,
okay, so you went with. I think you went with what? Draw. Yeah, here, draw. Okay, so we're just going with text. Yeah, that one. That one or that one. Any of those would work, and then you can write.
Wait. Is this one? Oh no, that's a circle. Mouse. Sorry. I had it before I selected the eraser.
Okay, it's fine. Just find the right. Find the right.
Are you sure it's the text one? Because the text one.
No, not text. It's this one.
Type.
Draw.
Yes, draw, and then which one?
And then it's this one. It's this one. This one's the thin line. Here's the thick line.
Oh, okay, I've got it.
Okay, you got it. Okay, 100%. Good.
Okay, yes. Okay, let me just erase this.
Okay, great. So yeah, try it. Let's see your workings. If you had to do this working, what would you do?
Okay, so let's multiply this. So then it's 3 minus 1. So will this then be -2? And then
no, be careful.
Are you not allowed to do that?
You can, but you haven't done it correctly.
Oh, it's a plus. Okay. A minus times a minus is a plus.
Yes.
Okay, so that would become -8. Okay, B, that would become 3, 6. Okay, then over, then this would become 6. A, 4.
Ooh, be careful. The 6 also needs to be multiplied.
Oh, okay.
Okay, because remember the 6 is also a number. The 6 just has an invisible 1. When you see 6 like that, it's actually 6 to the 1.
Oh, okay. Okay. Okay, so 6. So that would become 2. 6A. Okay, and then this would become B minus, -2. Then this would become C minus 4.
Yes, that's correct. Okay,
Okay,
now what
and
are you
then
busy?
now I can, yes, now I can start subtracting because we're dividing.
Okay,
So,
so now you need to simplify, yeah.
okay, so let's start with the A. Okay, but now it's a minus at the top. So 8, would that become 8 minus 4, so minus 12?
Yes, at the top. If you want to minus the 4 at
Yes.
the top, yes, you can do it that way.
So A, that would become minus 12. Okay, and then B, that is 6 minus 2, so that would become 4.
Ooh, no, it's 6 minus 2.
So then, okay,
Because remember, the exponent is negative.
okay, so erase. Okay, so then it would become 8. Okay, and then the C, that okay, that we can't do, and then okay, the 3 to the power 2 and the 6. Um, okay, that I'll probably leave. Okay, 6 to the power 2, then the C to the minus 4.
Okay, that step's good.
Okay,
And then next step.
okay. Next one, then okay, I can probably multiply this now. This will become 9. 6 times 6 is it's 60, 36. A minus 12, B 8. Do we have an answer? Not yet. Okay, so then next,
What happened to your C
I can
here?
oh yeah, sorry, C to the minus 4, yes.
Okay,
Okay,
now?
okay, anything that can go into 9 and into 36, maybe 3.
Go bigger. 9 can go into 36.
Oh, 36 divided by 9. Okay, so that's 4. Okay, so then this would become A minus 12, B 8, and then this will become 4, C minus 4.
Okay, that's good, but now you don't want negative exponents. So how do you get rid of the negative exponents?
Um, you have to yeah, you have to swap them around, or you can move them probably to the bottom.
Yes, you can move it to the bottom or you can move it to the top, correct. So final
Okay.
answer?
Okay, so B 8, C 4, okay, over 4, A 12.
Okay, and that's option?
Oh, option 3.
Yes, let's check if it's correct.
But,
What number was
okay.
this? This was number 9. Okay, when we did this previously, let's just double check. Yes, option 3. Perfect. Good job. There you go.
Okay.
Nice.
Just practice that one a bit tonight.
Yeah,
It's
so
actually
it's
a
the
very good
rules. It's the
example.
exponent rules.
Yeah,
That's the key. It's all
yeah.
about this. I'm just gonna delete the writing. Let me
Okay.
just get my. Where's my? Ooh, there. Let's just delete the. Okay, it's these rules. Do you see it?
Yeah.
Okay, if you don't have these rules, you're not going to be able to do those exponent questions. Yeah, you need to go and have a look at the rules here. It's not a lot, it's just 3 rules. There's rule number 1. Multiplying means add, dividing means subtract, and obviously raising it by a power. Okay, those are the
Okay.
3 exponent rules. And then something else just to remember. Minus 3 would be 4 to the 3. Okay. Right, negative exponents. All right, or something like this could be something like that. Does it make sense?
Yes.
Yeah, so that's something else to remember. Okay, so just remember the negatives and how that affects the working, and then just remember those 3 rules. 1, 2, 3.
Okay.
Okay.
Okay, so I'm just going to email you a screenshot quickly of the rules that I basically got. I think they call it a cheat sheet or
Oh, okay.
for tomorrow's exam.
You've actually made one. That's brilliant. Well done.
Yeah, but just for Vespri, I mean, I just want to verify that they're correct. I've just emailed it to you.
Oh, okay. All right, let me open it. Okay, I don't see anything yet. Still coming, I guess. Okay, I got it. Okay, so you've got rules for fractions. Okay, this is looking at a lowest common denominator. Well, obviously a common denominator. That's fine, that's fine. Here you're multiplying. So yeah, when you multiply fractions, you multiply the numbers at the top and you multiply the numbers at the bottom. When you have B and D as different denominators, then you need to find a common denominator. Yeah, these are normal fraction rules. Here are the exponent rules. Yeah, there's it there. There, product rule.
Yep.
AX plus AY, and then you've got AX plus Y. And then you've got quotient rule, AX divided by AY, then you've got AX minus Y. There's the power rule. X, A to the X raised by Y, then you'll have A to the XY. Yeah, these are good. And then this is power rule. When you have X, you can multiply the X into the variables when you have a bracket, okay, to remove the brackets. Fraction rule, it doesn't matter whether it's a fraction or a normal number. When you're multiplying out and you're getting rid of the bracket, you multiply the exponent in. Okay, so you'll have a to the x, b to the x. That's correct. Exponent 0 equal 1. That's correct. The negative exponent, see there's it there. Okay, so when you have a to the minus x, it's the same as 1 over a to the x. Okay, you make it positive by putting it in the denominator. And when you have a fractional exponent, so a to the x over y, it's the same as square root a to the x and then y outside. Okay, so if it's a, where's my writing tools? Okay, here. Okay, so just to show this one, okay, if I had 2 root 2. Okay, root 2 would be the same as 2 to the half. Yep. Okay, if I had square root 6 squared, okay, that would be the same as 6 to the 2 over 2. Okay, when there's no 2 here, it's invisible. Okay, if I had...
that's actually one thing I wanted to ask. At one of the examples,
yeah,
it actually ended up the square root of something and then to the power 2. So then you can just remove the square root.
Yes, you can. That's right. So if you have something like this, 16. Okay, square root 16 can be square root 2 squared. 4 squared. And that'll be plus minus 4. Yeah, so this is just looking at this formula is saying a to the x over y is the same as a to the x. That's correct. Okay, so it doesn't matter what you have. If you had something like this, a to the 6, let's make it a 3 here, then you would have a to the 6 over 3. Is that right?
Yes.
Yeah, those are just rules. And then here are the log rules. These are good. Okay, we've even used some of these in our in some of our past papers. Yeah, but remember, this is just one set of let's say rules. You still need to go and look at the for example, the consumer surplus, the producer surplus, all of those things.
Yeah, yes. I did add them here on my document.
Okay, that's good. So Yeah,
basically made a
with
list of all
yeah,
of them.
with those rules, those other rules would have come out of here, the study guide.
Yeah,
So
yes.
when you go
Yeah,
through the study guide, I would write down formulas that come up in different chapters.
yeah.
Yeah, so for example, in
Yeah, the
that
thing is,
chapter, I would write
yeah,
down the equation or just copy paste it. You can do it electronically. So for example,
yeah,
if I go to page, what is it, 13, 14, somewhere around there. Maybe just here. Okay, here's an equation. Okay, that's just the normal demand function, linear equation.
yeah.
Okay, that you don't really need. Okay, y equals mx plus c. Okay, they just write it in that format. Okay. All right, but equations like the ones we saw earlier, consumer surplus, producer surplus, those ones you need to write down. That you need to write down. Okay, that you'll need. Consumer surplus, non-linear functions.
Okay.
Okay. All right. So yeah, if you've done that, then that's good, eh? That'll obviously help you when you're looking at different questions. That's the key. The key is knowing which equations to apply when.
Okay.
Okay. How many past papers have you been doing over the last week? Just in terms of like prep. Like, have you been
Um,
doing questions and then checking questions, um, and like completing it just to get more confidence?
yes, I've done 2 or 3,
Nice.
and
That's
then
very
yeah, I've
good.
been
Yeah.
yeah, I've
So
obviously been yeah,
so in terms of workings, so for example, you had around 6 questions in the first paper, the October November 2019. So that means you could have done 24 out of 30. That's brilliant. That's your distinction.
yeah,
That's very
yeah.
good.
I'm quite confident with the linear ones, and
Yes.
obviously differentiation.
Okay.
I think I'm also not too bad at yeah.
Nice.
My big issues are obviously the rules that we did with the exponents now,
Yeah,
the
those can be quite
integration,
tricky.
yeah, the integration, and
Yeah.
then obviously learn and yeah, basically with E as well,
Oh, log base E.
exponential growth. Or yeah, yes,
Okay, log base E is ln.
yeah,
Remember, E is just a constant.
yes,
Okay, that you can plug into your calculator if they give you. Remember, we saw some of those other ones where you substitute, eh? And then
yeah,
you've got to
yes,
use
yeah.
the E.
They very easy. Yeah.
Yeah,
So
then
yeah,
those
then
are
I
quite
just use the
nice.
calculator. Yeah.
Okay, good. Okay, anything else? What other questions from this exam that you struggle with?
Um, I wanted to look at question 10,
This
but
one.
that's basically just using that rules again.
Yes, this is using that rule that you had that you just emailed.
Yeah, with the yeah.
Okay, which rule would you use? Let me open it again.
Okay.
Which rule would you use?
Okay, so for log, when you the quotient rule.
Yes. Okay. Why using quotient? Because of the minus. Do you see that?
Yes.
There's the minus.
Yep.
100%. That's exactly what you're using. Okay, then you've just got to apply it correctly. Just remember though, when you have a 3 or a 2, okay, you need to write it as an exponent. So let me just show you what I mean. There. Okay, 5x to the power 3, x to the power 2. Okay, when you have that 3 and the 2
Okay.
outside, you have to write it like that. So see, there's the quotient rule being applied.
Okay.
From this, I get to that using
Yep.
that
So
rule.
that moving it around, that's the power rule.
Sorry, say that again. Moving what around?
The exponent that you the in front of the ln that you made the exponent, that's the
Oh,
power rule.
oh, you're saying moving the 3 into that.
Yes.
Well, it's not quite the power rule, but it's just part of the arithmetic. Okay, because when you
Okay.
have a log is basically how can I say? It's an expression for an exponent, basically.
Okay. But
Yeah.
go back to that other diagram again, the rules.
Oh,
Then
okay, I see
click
what
the
you
third
mean.
one
You're
there.
referring to
Yeah.
this.
Yes. Yeah.
Okay, all right. Yeah, I see they call it a power rule. Yeah, I don't remember it as that. But when I think power rule, I'm
Okay.
thinking about derivatives, and that.
Yes.
Yeah,
Yeah.
but you're right. If you're applying what we just said here, you're using that. That's correct. Okay, yeah. So I
Okay.
didn't see that one.
Okay. Yeah. So okay. So then, in terms of that answer, so okay, then you'll move them to the exponents, and then you can use the quotient rule, and you can basically make it 1. Okay, and then equals 7. So
Okay, yeah. Because
learn 5.
remember, you had 5x to the power 3 over
Yeah.
x squared. Okay, if I apply the quotient rule and the power rule,
Yeah.
okay, then I've got this little bit here equal to 7.
Yeah.
Okay, then what do I do? I cancel. Then I've got ln 5x equals 7. Then what do I do when I have that? I write down
Just
this
a normal
equation.
log. Yeah. Yep. It's 8. Yeah. Log is the power.
Okay, then obviously I just have to apply it because this, if it's
Yeah.
ln, it'll be log e. Does that make
Log E.
sense?
Yes. Yeah.
Okay, and then I'm just applying that here. There. Okay, so ln 5x. Okay, so log e. Okay, so in other words, log e 5x equals 7. Okay, log e 5x equals 7. Okay, if I'm writing it in this format, okay, obviously 5x is the answer. So I have 5x equal to e to the power 7. That's how I got that. Okay, there's it there. See? From ln 5x equals 7 to log e 5x equals 7. Do you see that?
Yes.
And then I'm applying what I had here. 2 to the 3 equals 8. Log 2 to the 8 equals 3. And then I'm just writing down this. I'm writing it down in this format. Does that make sense?
Yes.
Okay. So I'm taking this and I'm writing it down in that format. Okay, so log 2. Okay, the 2 here is the base there. Do you see that?
Yes.
So what is the 2 here? It's the e. Then I write down the e. Do you
E.
see that?
Yes. Yep.
Okay,
Yep.
what is my 3 here? My 3 here is the answer. Do you see that?
Yep.
What
Yep.
is my 3 here? It's the 7.
7.
Okay, the 8 here is this. Do you see that?
Yep.
So here, the 5x is the 8. Do you see that?
Yeah.
That's how I get that.
Okay.
Okay, and then once I've got that, obviously you can solve for x. E to the 7 divided by 5. That you can plug into your calculator. Are you okay?
Yeah.
Sure.
Yep.
Okay, so I'm literally just taking what I have here and I'm applying it to this scenario. Okay, basically you've got this and then you've got that, and then you're writing this format in that format. Does it make sense?
Yep.
Okay. All right, good. Other questions?
The next one I think was 14. But yeah, that's again the one that we did in the previous one,
Okay,
the
so you do this one.
consumer surplus.
What formula are you going to use?
So yeah, it's going to be that integral one. Yep.
There's the formula. Do you see it?
Yep.
Okay, so let me go back to that page. Oh, I can't actually, I have to do it this way. How can we do this? Okay, let me do it this way. I want you to try this one, but obviously I want to write down the formula. So let me just get it. Okay, so let's copy that little bit. Okay, there's your equation. All right, let's go back to the question. There's the question. There's your equation.
Okay.
Okay. Do you want to write again on the screen? You can write on the screen.
Yeah. Yes.
Okay, you do the workings. Let's check. Consumer surplus.
Okay.
You're using this formula and you're applying it to that question.
Okay, so first I need the DQ. Okay, in terms probably of DP. So I can't remember, is that 1 over DQ? Yeah, so.
Okay, work through it. First step. Step number 1 is to do what?
Yeah. Okay, so first I probably, I don't have to differentiate.
No, you're not using differentiation, you're using integration.
Okay, so first of all, probably 25 over Q plus 2 times DQ.
No. Well,
Oh,
it's okay, but you're just forgetting that. There you go.
yes. Okay. Um, okay, and then I'm not sure. Am I supposed to use that 1 over U or?
No. Well, in terms of the integration, later you would have to.
Okay. So do I need to integrate at this point or?
Yes.
Okay.
Yeah. So this you need to bring it into something like that, and then from 0 to Q. Then
Yes.
obviously minus the PQ.
Okay. So first, let's get the. Okay. To get the Q, you're probably going to set the P to 0.
No.
Or.
How do you get the Q? How would you get the Q?
Um, oh, the price is 5. Sorry. Yeah, I
Yes.
didn't read
Okay,
that.
so maybe do that
Okay.
little
So
working.
5 equals 25 times divided by Q plus 2. Okay, so that means, okay, 5Q plus 2 equals 25. Okay, so that is 5Q plus 10 equals 25. So 5Q equals 2.5.
No.
Oh, sorry, it's 10. 15, sorry. Yeah.
Yeah, be
I
careful.
should,
Remember, it's plus 10.
yes, yeah.
So it'll be minus 10 on the other
Uh,
side.
yeah. So 5Q equals 15. Okay, and then so Q is 3.
Okay, so you've got Q as 3. Let's check if that was right.
Yeah.
Was Q 3 here? Yes, Q was 3 there.
Okay. So next then, yeah, this is the part that I struggle with. That I need to practice.
Okay,
So I'm going to get the integral from here. So that means obviously plus 1 divided by 1. But obviously you've got the Q plus 2 here at the bottom. So you're probably going to have to use that substitute rule or
yeah, that U. Yeah, because Q
that
plus
U,
2 would be
yes.
the U. Yes.
Yes.
Yeah, so if you had to work it out, you would have U, and then obviously U would be ln. Do you agree?
Yes. Yeah.
So
Yeah.
the function ln would be the 1 over x in terms of the derivative. So if
Yeah.
I'm doing integration, I'm going from here to there.
Back
So
to,
if it's
yes.
1 over u, I'm going to get an answer of ln x. So I'm going to have ln,
Okay.
so I'll have ln q plus 2. Does that make sense?
Yes.
Okay, so this 25 over q plus 2 would be it would be 25 ln q plus 2. There's the integration.
Okay. I just want to ask you quickly. Okay, so the first step that we did was using u.
Yes.
So what did we say? What did you set u to? So u was q plus 2.
Yes.
So
then you have
but
25
that,
over u. 25 over u in terms of its function would be
yes.
ln u 25.
Oh, okay. Because with ln you can move the. Why does the 25 move in
Because the
front of
25 is
the
the
ln?
constant.
Yes.
So the constant, it's 25 ln u. Because you're integrating.
Okay.
It's like when you had this, x squared.
Yes.
No, we can't do that one. There, this one. Okay, this would give you what?
Oh, yes.
Okay, it's the
Okay.
constant.
Okay.
It's the constant. The 25 is a constant.
Okay. Okay.
Okay. All right, so when you have something like this, maybe just to remember it, you will have ln, the bracket, whatever it is, and then just remember the constant outside.
Okay.
Okay, and then you've got obviously 0 to what? To 3.
Yes.
Okay. All right, so if
Then
you
you're going to
if you carry on.
substitute. Okay, so then I'm going to substitute 3 into here and then 0 into here. And then I'm going to divide, subtract them.
Yeah,
So,
you're going to have to substitute 3 and 0, yes.
yeah, 25 ln 3. Was that a 2 plus?
Yeah, it's a plus 2.
2?
Sorry, the writing's not so great.
Okay. Now I'm also struggling to write with this. Okay, and then this is going to be minus. And then this is 25 ln 0 plus 2.
Yeah, so 0 plus 2 is just 2.
Okay.
Okay, that's good. Yeah, so
Yeah,
far so
let's
good.
just make that 2. Now I'm going to have to practice tonight.
It's right. Don't erase that. That was correct.
Okay. I just wanted to remove the 0. Yeah.
Oh, okay. Yeah, that's fine.
2. Okay.
Okay, so now plug that
So
into your
then
calculator. 25 ln 5 minus 25 ln 2 is what?
Then 5 minus 25 ln 2. 22.907268.
Okay. And then what is your P times Q?
Okay. Okay. Obviously, the price is 5 times 3. It's 15.
Okay.
So,
yeah, 5 times 3 is 15.
minus 15. So that gives you 7.90726.
Yes. Option 3.
Okay.
Nice. Question 14, just to double check. Yeah, option 3 is correct. Yeah, same working, same calculation, same answer. Good. Is that right? Okay.
Yeah, like I said, I'm just going to have to basically practice it tonight.
Okay. But remember,
Yeah.
Maybe what I would suggest doing, because it's a open book exam, maybe write
Yes.
down these workings for one of them and keep it aside so you can see the steps. So if you get a question that's similar, you just follow the steps.
Okay.
Okay, maybe do that. So have an example question to reference.
Okay.
All
Yeah,
right,
no,
this
I
is a
think, yeah,
nice
that's a
question
very
to
good idea.
reference in case it comes up again.
Okay.
Okay, all right.
Because, yeah, I think from all of the exams, I think there's usually at least one. And that,
Correct.
yeah, I think, and
Yes.
yeah, but I'll probably leave it until last because
That's a good idea.
they usually take up a lot of time as well.
Correct. Yeah, they do. So
Yeah.
that's good exam technique. Definitely do the 24 questions you can, get them right. Don't rush them though. Make sure you get the right answer because you don't want to make silly mistakes and then you lose out on some easy marks.
Yeah.
And then once you've completed those 24, then you can work on those last six that are tricky.
Okay.
Okay, good. All right. Other
Um,
questions? Do you have more?
next one is question 23.
Okay, 23. Okay, let's just let's just clear everything. Okay, 23. There we go. Okay, yeah, 23 is quite tricky because you're looking at the derivative. All right, and you've got a square here. So obviously the first step is to multiply out. 20, if I'm multiplying out, actually, let me think about this. If I'm looking for the derivative, you can probably use chain rule here because you've got this bracket squared. So you could say u equals 20 plus 20 ln q. Okay, then you'll have dq over d over dq equals u squared. Okay, then obviously that'll be 2u. And then obviously du over dq here, no, du over dq, yeah, dq is right, equals, derivative of this would be, what is the derivative of that? Let's see, ln x becomes 1 over x, so it'll be 20 over x. Okay, so now I have this, d over dq, okay, equals u squared. Okay, so to get, what do I want? I want, this is d over dq. I want the derivative, so I know the derivative is going to be u squared. So 2u. All right, so 2u is 2 times that bracket. Okay, and then I need to bring in this. Okay, so, why did I write x here? Okay, q. Alright, so if I bring that into this, because you've got, this would have been d, this is d over d, du over dq, that's right. This one is d over dq, du. Okay, d over du is equal to u squared. Well, 2u. Okay, so then I've got d over du and I've got du over dq. Then I can multiply. Du over dq times d over du. Cancel, cancel, gives me d over dq. Do you see that?
Yes.
Okay, so that's what I would have done. So maybe just to show the rest of it. Where's it? Oh, it's on this side. It's on the screen. Okay, so is it okay with chain rule? Are you happy with what I did there in terms of chain rule? So I made the
Yes.
bracket equal u.
Yeah.
Okay, then I derived d over du, which is now u squared. Okay, because of the u substitution. Does that make sense?
Yes.
Okay, so if I find the derivative of du, then I've got 2u.
Yes. Yeah.
Okay, because I've got u substitution, the u equals this, 20 plus 20 ln q. Okay, this needs to be derived, so du over dq is 20 over q. And then you just need to multiply those two together. du over dq times d over du equals d over dq. So you're taking this and you're multiplying it by that. Okay, and if you do that, you're going to get the right option. Okay, this is what question 23. Let's see here, 23. Yeah, there's the u substitution. There's the du over dq. That's what we had there. There's the u squared. Okay, so there's the 2u. And I just multiply there. dy, well, okay, I used y here. I just made this thing equal to y. It doesn't matter. If you get rid of the y, it's the same thing. Okay, so d over du times du over dq. Okay, then obviously I'm cancelling. Right, so I had this 2 times 20 plus 20 ln u. Okay, multiply that by 20 over q. All right, that's what I've got there. Then I just followed that arithmetic. Multiply out, factorize, and then I got option 2.
Okay.
Okay, sure.
Yeah.
Okay, all right, so it's just a step-by-step process. With this one, you need to do chain rule first. Chain rule first, then derivatives. Then just remember to multiply them together to get the right answer. So you're doing two separate things, combining it, and then working it out.
Okay.
Okay.
I think the next one was 25.
Okay, integration here. There we go. All right, so integration, when you have this, what are you thinking about?
Probably that substitution rule, the 1 over u, or...
Yes, okay, well, similar, correct. Okay, so let's just move that across. Let's go back to this. Integration. Let me show you the function. Let's find it first here. Differentiate, integration. Okay, integration. There's substitution, 96. Oh, I can't navigate with that. Okay, so okay, page 96. Here, integration rules. I'm looking at the substitution one. 96. There. Integration by substitution. There we go. Okay, this is what you're looking at. Okay, it's basically reverse chain rule. Alright, so when you apply it, you have to make that equal u. Okay, once it's equal to u, then you follow through the process. Right, so for example, if you're integrating this, okay, this needs to be u to the 3. Do you see that?
Yes.
Okay, so once you've got that, then you can find the function, okay, by going backwards. All right, if I go backwards, I get that as my integration. Do you see that?
Yes.
Okay, once I've got that, then I need to go back and look at my u substitution. Okay,
Yep.
du over dx is going to be 4. Do you see that?
Yep.
Okay, so when you have du over dx equal to 4, because you've integrated here using du, okay, what is du equal to? 4 dx. Do you see that?
Yep.
Okay, so dx equals du over 4. All right, so I'm going from this step to that step. Plug in the u, okay, and then insert the du over 4.
Yeah. Yep.
Okay, and then I solve, and I get that. All right, so it's kind of like reverse chain rule. So if you're looking at this, okay, what are you going to use? U equals du over
Yep.
dx is 2. du equals 2 dx. Do you see that?
Yep.
Dx equals du over 2. Does that make sense?
Yeah.
Okay, and then you've got the integration of, what is it? It is 2 u to the minus 4. So that's going to give me 2 to the u minus 3 over minus 3. Does that make sense?
Yep.
Okay, so that's going to give me 2. Okay, so this is minus 3. So I'm going to have minus u to the 3. Does that make sense?
Yeah.
And then here, I need to substitute in u. Okay, and then I just need to follow through the steps. Okay, so I'm just going to show that. Where's my workings again? Here. Okay. Are you happy with the initial steps?
Yeah.
Okay, good. All right, so then you've got to plug that in. Okay, where's it? Here. There we go. All right. Okay, 1 over minus 3. Okay. Oh, hold on. What happened here? Is this the right question? Yeah, this is question 25, hey? Yes. Okay, oh. All right, here's the 2. There's the 2. That's why it's cancelling. Okay, so you've got the dx. Okay, there's the 2 times a half. All right, final answer. 1 over minus 3 brackets 2x plus 1 to the power 3. Option 3. Okay. Right, so the hard part is the initial bit. Are we okay?
Yeah.
Sure.
Yeah. Yes. I'll just have to go over this again tonight. And
these are quite tricky
yeah.
because you need to use the u substitution.
Yeah.
Okay, when you see something like that, step number 1, get u. Step number 2, get the integration. And then at the end, combine the 2 together.
Okay.
Okay, because basically I'm just multiplying this. Okay, timesing it by 1 over 2. Cancel, cancel. Answer minus 1 over 3. U, what is u? 2x plus 1. To the 3. See?
Yep.
That's all. Okay.
Okay.
All right. Were there more questions?
No, I think that was basically them. Yeah, I think the other ones will just basically be the same as these ones that we just covered.
Okay. All right. So, yeah, I think you said you're on study leave, hey?
Yeah.
Okay, that's good. So at least you have,
today and
I mean,
tomorrow.
you can probably take a break now. I mean, we've done quite a bit. Maybe take a break, go get some coffee, get some fresh air.
Yep.
I don't know if, is it raining in Pretoria? It's actually raining here in Joburg.
No, we got a notification now that we might get hell.
Oh, okay,
But
you might have hell later on. Yeah, that's quite bad. So,
Yeah.
but it's actually storming outside by me. But yeah, so yeah, maybe take a break, relax a bit, just kind of gather your thoughts in that because obviously it can get quite hectic. And then maybe after an hour or so, and then maybe come back to it and have a look at the rules again. But my best advice would be to take a past paper and write down the workings for the difficult ones. For example, this one, you can write down the workings, or even that other one we did, this one.
Yeah.
You can write on the workings, and then you've got an example that you can reference. So if a question comes up that's the same, you can follow the approach. That's why I like referring to the textbook, because the textbook shows you the approach, and then you just need to apply it correctly to the right scenario. So, for example, when you get a question like that, similar, okay, if it's similar to this, you need to follow substitution.
Okay.
Yeah, and if you have those templates with you, if you have those examples with you, that's going to help a lot.
Yeah, no, definitely.
Yes.
Yeah.
Okay.
And I mean, yeah, like I mentioned, I'm gonna try and do all of the other ones
Nice.
first, and then leave these ones for last. I mean, the ones that we covered now, I mean, they're not even, I'd say, 5 or 10% of the exam. So
Yeah. Well, let's see, five or six in the exam. Yeah, it's about. You can probably do about 25 out of 30.
yeah, yeah,
The last five is the challenging bit. That's going to give you that extra 25%. But it's worthwhile trying, but don't stress too much about them. Rather get all those other ones done quickly and
yeah.
accurately. Don't make mistakes with them. Take your time, make sure you get them right, and then you can focus on these more difficult ones later. That's the right exam technique.
Okay.